Good morning, everyone, and thank you for being here. I think we can start. Let me introduce myself briefly for those who don't know me. I'm Daniela Smiraglia. I'm an ecologist, and I work at the Italian Institute for Environmental Protection. And in MONALISA project, I'm involved in the work package that deals with the developing of a methodology for the assessment and monitoring of land degradation and desertification risk. In this context, emerged the need to do a check and analysis of all the available data set that could be useful for our work, including land cover and land cover classification systems. And Gregory Giuliani, the professor Gregory Giuliani, proposed to do a presentation regarding the Living Earth framework that he and his colleagues are working on. Thank you, Gregory. I'll give you the floor immediately. Please briefly introduce yourself, and then you can start with your presentation.
Okay. Thank you, Daniela, and thank you, everybody. That's a great pleasure to be with you this afternoon to give you this overview of what we have in mind with my colleague, Audrey Lambiel, which is our PhD student in the frame of MONALISA working here at the University of Geneva. So my name is Gregory Giuliani. I'm a senior lecturer at the University of Geneva at the Institute for Environmental Sciences, and most of my research is related to land degradation and also the use of land cover change at different scales. And in Switzerland, we have operationalized also the Swiss Data Cube. So our team also is in charge of managing the Swiss Data Cube for the Swiss government. But really the idea of today is to show you, I would say, kind of proposition we have for MONALISA. And this is really the topic on which Audrey will work in her PhD. And the idea, so I will start sharing my slides. Here we go. It's going to be better. So now I hope you could see my screen. Really, the idea is to come with something that is more integrated than the traditional, I would say, land degradation assessments. So really, if we take, I would say, some distance and look more broadly to the topic, obviously it's completely rooted in this aim of this global recovery of ecosystem and environment, because we all know the issues we are collectively facing at the global scale. And now we really need also, if we think about the Sustainable Development Goals, we need to provide understandable, viable, and accessible solutions for planning the future, and try to recover the key ecosystems across the globe at all scales, from the local up to the global. So going to the land degradation, we also all know that it's a global issue. We have this huge challenge posed by also the SDGs to restore by 2030 1.5 billion hectares of degraded land across the world. And you remember also the last COP, UNCCD COP, and they were stated that more than 40% of land is currently affected by land degradation. So it's a really huge issue we are facing, and there are many causes and effects. As we all know also, it's just a kind of summary of the main causes and effects at different scale across the world. And one of these many challenges we are facing for monitoring and assessing land degradation, there are many challenges. One of them is the data availability and quality, especially with the lack of ground data. There are also gaps here in terms of temporal frames, so limiting also the monitoring capabilities. And obviously, the spatial resolution is a key bottleneck. In terms of methodologies, there are some, let's say, inconsistencies, but especially there is a lack of standardization. If we look, for example, in MONALISA, we're aiming to use Medallius and the SDG 1531. They are conceptually quite different. So they are showing different aspects of land degradation, and we need to find a way to integrate them so that we can see the multiple dimensions of land degradation. Also, the indicators are quite, from time to time, they are quite complex to compute. And the scalability also of the methodologies from the local to the global, it could be a big challenge. Then related to that, to the scalability issue, the integration of different data sources is a key element also to consider, especially the different incompatibilities in terms of data sources. One key aspect is the dynamic and the multifactorial nature of degradation, so the different causalities and the lag effects, for example. So this is also an issue we need to consider. Also monitoring degradation, is it only related to land use change? So we need to identify the different factors related to the different drivers of change. And also we need to consider all the socioeconomic aspects and potentially also the institutional barriers and the acceptance to new tools for monitoring land degradation. So maybe you came across this really nice paper from Francesca and other colleagues back in 2020, and in the conclusion of this nice paper, there is this sentence saying that there are still need for some technical improvement, especially regarding the land degradation neutrality indicators, to have a proper view on land degradation, also integrating climate data, and have a better representation of both physical and chemical phenomena. So this is a challenge posed by Francesca and colleagues, and we need to consider that. And if we take this into consideration, I would say that currently we are mostly looking at the state impacts. And now one of the challenges also we need to consider is how we can go into an integrated system and really a driver pressure state impact response, so this DPSIR framework, so that we can really move towards this objective and potentially also look at the future situations of predicting future landscape. And obviously this is strongly related with land cover. And one of the basic assumptions we can make is that land degradation is, let's say, mostly reflected in land cover change, not only. And just to remind you also that there is a really nice e-learning training course led by FAO on using land cover information for monitoring the SDG 15. So it's a really good training material, and really encourage you to follow it. It's really super interesting. So the key question we are aiming to answer through Audrey's PhD is how we can develop, or can we develop something that is really integrated, consistent, standardized, scalable for monitoring and assessing land degradation. So it's a huge challenge, obviously. And we came across with a tool called Living Earth, and I will show you afterwards how it works and what is it. But Living Earth is a standardized framework designed to provide a consistent, flexible, and scalable classification land cover system across various spatial and temporal scales, which is one of the key challenges we need to consider. It supports different types of monitoring, obviously, broadly speaking, environmental monitoring, but also land management and sustainable development initiatives. And it has a really modular structure that allows to accommodate different features, both environmental and anthropogenic, and enabling the users to harmonize data sets from the local to the global. So we think that's what these key features, I would say, or key capabilities, this is something that could be potentially of interest for our project. So Living Earth, in short, it's really a kind of, let's say, software package supported by the Open Data Cube, but it can use not only the data cube, so whatever raster data types we can ingest into the models. And it's really based on the use of Earth observation data, not only from satellite, it could be other types of Earth observation data. And then these Earth observation data, we translate them into environmental descriptor. So this could be, for example, a canopy height information, a simple NDVI to map vegetated area versus non-vegetated area, and so on and so forth. And we can add as many EDs as we wish into the system. Then, based on that, we have different rules within the software that allows us, based on the environmental descriptor, to classify the landscape and generate land cover maps and habitat maps. And if we have at different time steps those land cover maps, then we can look at the changes and and have a kind of evidence-based change system. So we can account for the changes. And then lastly, we can even think about potentially also using that information, so basically the knowledge from the past, to understand the potential futures according to different scenarios of change. So this is really the pipeline when we use when we build the living Earth system. And the living Earth system is working using the Earth LCCS classification system, because we think that's the best way to, in our case, to map land cover. So as you perhaps know, so the land cover, the LCCS system, it works at 4 different levels. So we have two main phases: the dichotomous phases, phase targeting the first 3 levels. So at the first level, you identify vegetated area versus non-vegetated area. And in that case, you can just use a simple NDVI in that case. Then at the second level, you identify terrestrial areas versus aquatic areas. So here we can use also a simple water index out of satellite data. And then at the third level, you identified cultivated areas within the more vegetated areas, or the artificial ones for the non-vegetated areas. And you end up here at the level 3 with 8 basic classes of land cover that are more, let's say, natural in a certain aspect than just a single class like forest, water, or whatever. Here we have more, it's more descriptive, but it's also more consistent in terms of taxonomies. And then at the 4th level, so this is the hierarchical phase, here you can add whatever information you wish to describe each of these 8 basic classes. So if, for example, for the natural terrestrial vegetation, so the one in green, in dark green, then you can add information on canopy height, on leaf type, on life form, on phenology, on stratification, and so on and so forth. You can accumulate through environmental descriptors, and you can add more details through this phase. And then you can even add at I would say a 5th level, you can even add additional EDs that are not well used, I would say, or for example, the topography or the lithology or the soil attributes, you can add them within the model. So you see, this is really something that we can enrich incrementally through time when new information is available. So the environmental descriptor, they are mostly categorical or continuous. You see a few examples of them, so a lot of descriptor for the vegetation, but you can even look at the marine environment, the snow, the soil, the water, the urban areas, the terrain, and so on and so forth. So you have many descriptors you can add. And just to give you a kind of, let's say, overview, if we look at this small sketch with a pot with a small plant into it, I would say the broad description, so basically the level 3, it's a natural terrestrial vegetation. And then if we add information at the level 4, we can say it's a woody shrub with a canopy cover between 40 to 65%, with a canopy height of 50 centimeters. It's broad-leaved, evergreen, and blah, blah, blah. We can add many details, and we can even add these additional EDs if we have any information, for example, on above ground biomass. We can say that it's 10 kilograms in that case. So you see really the concept rooted within the classification. So it's also to give you an additional understanding, I would say, on the way we construct these land cover map. So the level 3, it's the basic sketch. If we look at MONALISA, in that case. So we recognize the general form of the painting. Then if we enter the level 4, then we add all the details regarding the landscape, the figures, and the person we are drawing. And then with the additional LEDs, we can add a little final detail like the frame or the finishing touches. So we think that's also a nice way to present the way we will map that. And as soon as we have this land cover map, and then let's assume that we have a time series of land cover map, then my colleagues, so Living Earth is a system that has been built by colleagues in Wales, by Professor Richard Lucas and his team, together with colleagues also in Australia, within Geoscience Australia, and now in Switzerland, within our team, we are also contributing to that global effort. So they set up also an evidence-based change framework, mapping 77 impacts and identifying 144 pressures. And then they combined these 77 impact and pressures to have a 246 combination impact pressures. So then we have, I would say, a kind of DPSIR framework based on land cover change we can set up. And just to give you a really quick example, if we take again the part with the plant, so we can identify both conversion, so a change in land cover class. So for example, the vegetation has been cut, so it's becoming a bare soil. So in that case, we have a conversion, but we can also identify through the framework what we call modification. So we remain in the same class, but then thanks to the level 4 information, we can identify that there is a change in terms of state, for example. So the vegetation is dying. It's because, for example, of drying conditions, and then the vegetation is dying. So we can identify this thing, and then through the evidence-based framework, we can identify both the impact and the potential pressure behind it. So then you can obviously map the changes. So no changes, the gain or the losses. And then, well, this is a complicated slide, but really the idea is that we have 77 impacts already gathered through these environmental descriptors, and then they are linked with 144 pressures. So you see, for example, if we have an impact like the vegetation dieback, then you have different types of pressure that could be potentially identified with the help of level 4 or even additional environmental descriptors. So that's really the basic concept behind that. So just to try to recap, obviously we construct the environmental descriptors, we generate the land cover map, we observe the change, we look for the evidences for impacts, we identify the pressure, and then we link obviously them. And then the future landscape, it's another story, but that's also on our agenda to model future landscapes. If you're really interested in this framework, there are really two main publications. So you have the name of the publication and the DOIs. So I really encourage you to go through. I think that's really key. And just to show you really in action, just to mention that Living Earth has been implemented in Australia. So now it's fully operational for monitoring land cover change in Australia. Same in Wales. Also now they are generating, based on Sentinel-1 and Sentinel-2, regular yearly land cover maps at the national scale. It has been tested also in Malaysia, in Papua New Guinea, and now we are operationalizing also the concept now in Switzerland. And just to show you in Switzerland what we are developing, so basically we have the different data sources like the Swiss data cubes. Also, we gather some additional environmental descriptors directly from the Copernicus services and or other national data sources. Then we have script that allows us to generate the level 3 and level 4 layers. Then we use Living Earth to generate the land cover maps. We even have within the framework citizen science app that you can install on your smartphone or tablet to validate the land cover maps. So you can take pictures and qualify the land cover classes. And then we have all the different notebooks for monitoring the changes, like the change framework, also the landscape mosaics and others. So it's really looking at, let's say, the past, present situation, and we'll have a postdoc students really working on the future component. So once we have the time series of land cover change, then we'll model that according to different scenarios of developments in Switzerland. And it's really also rooted in this concept of data, information, knowledge, understanding, and then wisdom to connect with, let's say, the stakeholders so that they can take sound decision to manage their land. And just to really a quick example in Switzerland, this is a level 3 map of Switzerland using Sentinel-2 data. So you see the 8 basic classes. Then with additional descriptors, especially those related to snow and urbanization, then we have 32 or 37 land cover classes map for the entire Switzerland. And if you zoom in, for example, here in the central part, so you see the level, again, the level 3 and the level 4. So you see many details appearing on the map. And if you zoom in, you can even see here, for example, different types of vegetation, of cultures, but also in the urban areas colored in red. Also, for example, the urban density. So you have already an idea or an estimate of the urban density across here, in that case, the entire Switzerland country. So it's quite useful, I guess. And what we already have implemented also in MONALISA, because we think that's quite important. We have implemented this model from the GRC called the landscape mosaic model. So it's a way to reclassify land cover maps into 3 head members. So the developed, so it's more the urban, the agriculture, so it's the blue classes, and then the natural landscape. So you can remap, I would say, your land cover maps through these three basic classes. And then within this ternary diagram, you can identify the different proportions of urban, agriculture, or natural. And it gives you an insight also on the impact or the changes in the landscape. And then if I skip that, just to show you the example. So we implemented that. So now we have the full algorithm as a Jupyter notebook. So it's a moving window that is looking and calculating the proportion on a per pixel basis of the 3 end members. And then you are able, so based on the land cover, you are able to manage also see and look at the different proportions. For example, the AD classes in violet, it's mostly agriculture, but with a little urban areas into that moving window, and so on and so forth. So you have the different, let's say, mixture of possibilities according to the landscape. And what is interesting is that then you can look at the different axes. So you can look at the agriculture, where the agriculture is dominant, where it's subdominant, in that case it's coded in yellow, and then where it's minor, it's in gray. And then you can look in the same way for the natural aspect or for the developed or urban aspects. So then you can look at the urban density, let's say, according to that. You can then compute also the diversity of the landscape. So whether it's uniform, so you have a single class, whether you have 2 classes or more than 2 classes. And then you can even, based on the information we have on both agriculture and the urban areas, you can estimate the anthropic intensity within your landscape. And this layer, for example, we think it might be extremely useful to assess whether, let's say, anthropic impacts are important in terms of land degradation. And then you can even calculate the naturality of your landscape, because we have the proportions. So we know areas where you have 100% naturality, where on the other end you have 0%. So the key question now, looking at living Earth as a system, is how we can benefit from living Earth within our project. And we think that there are many aspects where we can interact with living Earth and use living Earth. The first one, you remember, for those of you who are part of the task 4, we had a call recently on the task 4.1, and one of the key requirements that was raised is we need consistent time series of land cover. So this is one thing we can easily, I would say, somehow easily generate for each use case area. We can generate using living Earth a consistent time series of land cover. Then what is also extremely interesting is that modes, we already mapped that. So Audrey and other colleagues did that for both the SIE and the SDG layers. So they mapped all these layers and living Earth framework. So, and we say that basically the level 3 is the land cover and the level 4 could be the different land degradation attributes according to the SIE and the SDG. And most of them are already layers that we could ingest within living Earth. So we started to map that. So most of them are already mapped, thanks to Audrey, Thomas, and Antonio. And what is also interesting is that I would say the data already produced and used in MONALISA could be integrated also within the system. So it's not, we have not wasted our time if we go, I would say, that way. So it's also a positive argument for us. Then if we make the assumption we have built this system, what could be really interesting is that we will end up with a stack of key layers for land degradation monitoring and assessment. And then we will be able to look really at the different and multiple dimensions of land degradation. So we can say that at the end, we will end up with a kind of land degradation data cube with the different soil attributes and different key layers we want to integrate within the system. Then what is really, really interesting, I guess, it's the multi-scale capability. So we will be able, through this system, to integrate both local, national, and regional data sets. So let's assume that we can start with, let's say, Sentinel-2 data to generate the level 3 maps. And then you made a drone flight on a really small areas in Sardinia or whatever region of the project. Then you can just replace the layer with the drone information. And then you have a more detailed view on the same area with mixing the different information coming from the different data sources and harmonized within the system. So we think that's also an argument that could be of interest for the different use case areas. Then, as we all know, one of the key issues is to identify the main drivers of land degradation. And we think, thanks also to the landscape mosaic module that we have implemented in Living Earth, it could be a way to simply, I would say, identify more the natural land degradation versus more the anthropic one. Let's assume that we have a land degradation map like this one generated by colleagues from the University of Bern in Switzerland. Then if you cross that information with the anthropic intensity and the naturality layer, then you can account looking at the areas where you have the degradation and which of these two layers, for example, could be the main one. Well, the weight is more important for, let's say, anthropic intensity or the naturality. And if it's the naturality, then we can make probably the assumption that it's more related to climate change than a strictly anthropic impact. Then something that we also want to do with Audrey is to expand this impact and pressure framework, but with specific land degradation information. So we can then expand that evidence-based change framework with specific information on land degradation. So we think that's also an interesting aspect of the approach. And then, depending on the data availability and the capacity we could develop across the project, then we think it could be potentially a first step towards, let's say, a dynamic land degradation monitoring and assessment system, as we can see on those animations. So this is really ambitious, obviously, but we think we have at least the main elements to go towards this objective. And finally, I would say that's also a nice and effective way of linking different work packages within the project, and especially the work package 2, 3, and 4. So that could be a kind of, let's say, element within the MONALISA project that could act as a glue between the different VPs. And just before finishing my presentation, I would say that also just to mention, we are involved in other European projects, 2 of them, Nostradamus and Landshift, and we are also expanding this work, developing a software package called Living Earth in a Box, where once installed, basically you have an open data cube together with Living Earth. So basically, if we make the assumption that through MONALISA we expand Living Earth with, let's say, a land degradation model, then it's going to be also reflected within this Living Earth in a Box system. So it could be available for anybody around the world to monitor also land degradation. So the perspective and the next steps for us within the project to implement Living Earth for land degradation, obviously we need to look and all together, not only us, and define the soil attributes that we want to integrate within the system. I think this impact and pressure specific to land degradation could be extremely impactful, let's say. Obviously, there is this idea and aim to look at the magnitude and severity of land degradation. So we need to think about how to integrate that within the framework. We need also to consider uncertainty, because this is, I guess, something quite important to communicate also to stakeholders about when we model anything, then we need to have an uncertainty map at the end. And ODRE also is aiming to look at the end also to the impact of land degradation in terms of ecosystem services. So what are the impacts when we have land degradation on especially the multifunctionality of ecosystems? So this is something we really want to explore, and this could be really connected with the work we're doing. And obviously, we need to also consider the LDN targets, because I guess that's something that is extremely important also in that regards. Obviously, we are open to any other ideas if we think that's something relevant we are proposing. And just to, before finishing, really emphasize one thing is that this is, well, one suggestion we make for the project, for the benefit of the project. This is something we will certainly and move forward within our team. But obviously, this is not just a University of Geneva idea, but really something we are aiming to collaborate across the project and co-create or co-design this solution together, because we have a huge expertise within MONALISA, and I can really guess, and we within our team think that's the best way to move forward. It's through collaboration and co-creation. So if you think that's of interest, so we are pleased to discuss with you and work with all of you on this topic. And with that, I'm done, and I really would like to thank you for your attention.
Thank you, Gregory. Thank you very much for this interesting presentation. I appreciate very much a lot of information that you gave us. First of all, the idea to make these maps, the land cover maps, not only maps with a structure information, but also functional information. That it's very, very important, because in this way, the land cover maps are not only a photograph of what there is, but there is a lot of information on how they work, how the ecosystems works. Also, the difference between conversion and modification is very, very important, because what is really is a change, a land cover change. So this is the question. And I think that it's very useful also the way to link the pressure and impacts in the land cover information to make these maps useful for land management, for land use, for sustainable land use management. So I have a little question regarding. Alej, please mute your computer. Thank you. I have a little question regarding the fourth level information. I would like to know if the information, the fourth level, are only descriptors or they are criteria to classify the fourth level.
This could be both, in fact, because you can have continuous or categorical descriptors, but yet then you can add also the other types of information within the system. Basically, it's going to be more an addition, what we call an additional descriptor, but this could be easily added within the system. It's really flexible, and Audrey has already started to code a way to integrate additional information that is not really what's in, strictly speaking, in the FAO LCCS classification schema.
Okay.
And Audrey has a comment. So
yes, there are two hand raised. Christina first, Christina Tarantino.
Okay, thanks. Many thanks, really, Gregory, for your presentation. I can say that I worked, in particular, my group worked with Professor Richard Lucas in the framework of an Horizon 2020 project called Ecopotential, also with Ioannis Manakos. And in particular, we worked at the starting developing of this framework. In particular, so I know that now the framework, the system surely has been improved. I remember that it is really based on a rule-based system, and in particular it depends also the level of accuracy or reliability that the system can be obtained depends in particular from the layers that we are able to feed in input. For example, if we are interested to a very accurate identification of the parcel in an urban area, for example, we need to provide to the system a cadastral map, for example, to obtain a reliable result. So I think that my opinion is that for application at European level, at country level, the system is really okay. It works well. My worry is that its application on a local scale, it's not so simple, because in fact, in our experience at the time of our project, we obtained that the accuracy at the local scale for local scale application was not so high. And so my idea is that it could be a very good idea for the activities of work package 3. But in any case, I have some perplexity for the application at the local level.
Okay. Oh, thank you. That's good. That's good to know.
And Mirko Barbero, please.
Yes, hello, good afternoon, and thank you very much for the presentation. I'm really happy to participate to this workshop. I'm not a researcher, I'm a policymaker, so I really believe that it's very important and useful to strengthen the science policy interface. That's also why I'm participating. And so I'm trying to think how all of this could be used by policymakers and to make the difference, because we have seen, so we have prepared the soil monitoring law, and we have seen that data were used to show that there is a problem, and now we want to solve the problem. So the key point is really, are we able, so those data are enough, are usable, so that they can make the difference for policymakers to take the action and change, reverse. So my question to you, have you do you have evidence, or have you tried to see whether those data actually can be used and make the difference in not in describing but in reversing actually land degradation? This is, I think, is key, because we have seen when we have tried to use such data at European level, we have seen that, for example, they were not enough precise on some elements, or they came too late. So I've seen some dates 2018. Now they would be for some points quite old data. Or they may miss the key information on soil, for example, soil status, instead of land cover. You see, there could be a lot of issues for which you could not be able. Thank you.
So, well, thank you first of all for your question, because I think that's extremely important, and that's something we hope we will be able to come up with a kind of, let's say, solution to close that gap between science and policy. Obviously, this is going to be if we go towards this objective, that's going to be really the first time we will apply living Earth related to land degradation. The only really example I have related to the use of such a system for, let's say, policy implementation, or in links with policies, it's really in Wales and in Australia. And I know they are really using living Earth in an operational way to set up policies and look and monitor on a regular basis, because, for example, in Wales now they are producing those kind of maps on a yearly basis. So they're really, I would say, tackling this challenge of outdated data, or let's say data that is coming too late. And they are really provisioning land cover and habitat maps on a yearly basis. And they can really, despite the fact that obviously there could be some errors or biases or whatever, so you can still look at the changes on a really regular basis and start and really understanding the dynamics behind that. And then in Wales, and this is the example I know more because two of my colleagues now working with us, they built up the system, and they showed us basically that it was based on a request from the government. So they are really using the tool for their policy mandate. So that's really a key achievement for them, but that's a long way to go, I guess. But at least from a scientific perspective, I think we can really show the benefit of a more, let's say, dynamic system than these one-shot maps that we can have from time to time, and then we make this kind of inference between the two time steps. So I guess that's the way to go also. But that's a huge challenge, obviously.
Thank you, Gregory, for your answer. Mirko, would like to say something more?
No, that's fine. Thank you very much. Indeed, I've seen with pleasure that you intend to integrate the soil aspects into the system, because this is key. There is a work of colleagues in the Joint Research Center of the European Commission who have proposed, let's say, an update of the land degradation assessment by integrating all the aspects, known and measured aspects of soil degradation. So there you can probably get some ideas as well. Yeah.
Sure.
Thank you.
Thank you.
Saverio, please.
Yes, thanks a lot for this presentation. Very interesting. First a comment and then a question. The comments, diciamo, are definitely more optimist than Christina on application on a local scale. I see the problem raised by Christina, and you raised also the problem of uncertainties, that the framework need be nicely integrated with uncertainties to be applied at very local scale. But I think that data-driven on single layer could marry quite well with rules across layers. So I think they are interesting. Is a very interesting framework. The things that are not totally clear is the part of the original UN land degradation framework disconcentrated on the land cover one, rightly actually. It included the continuous data of the land cover, but I'm not totally clear exactly how the productivity trends are exactly framed within here. you have diciamo, phenology summary statistics that are put in the classes, or actually you have directly trend change in land cover change framework? I'm not clear exactly.
That's well, thank you, Severity, because this is a really good point. And indeed, related to the SDG 1531, the information we can potentially add as environmental descriptor within the system is really, I would say, the basic phenology information. And then, because then basically you have a stack of maps, then you can easily extract the trends, the trajectory, and all the descriptors related to the SDG. So basically, this is why I was mentioning this idea of at the end coming up with a kind of let's say land degradation data cube, because then once you have the data, you can look at the different ways, I would say, and accessing the data and then generating the data. So once you have the cube, basically you can generate, let's say, the SI view, the Medallius view, or you can generate the SDG 1531 view, or whatever other types of land degradation assessment. And then, because it's using the same data or the same framework, the same location, then you can start. Well, you remember the discussion we had also in the work package 3 about this comparison between the Medallius approach and the SDG 1531, whether it's measuring two different things or there are overlaps or not. This is something where it's still a question mark. So then you can start really questioning the system. I suspect this is an hypothesis we can make for the moment, but we can really look at these different dimensions and start basically understanding more the dynamic aspect of it. Yes.
Nicola, please.
Let's activate the mic.
Yeah.
Thanks, Daniela. Thanks, Gregory, for the presentation. Thanks for the presentation of this framework, because this was exactly what we need for the land cover part from the perspective of the SDG. This series of coherent land cover maps, that's what we need, especially because, like Barbero said, the Corinne it's out of dated nowadays, so we need something new. A question is about the landscape mosaic, because I think it's an interesting point of view to describe the land cover changes. Do you think it is possible to, let's say, to assess the magnitude of land cover change degradation through this kind of model? I was thinking about a sort of naturality level or anthropic level, the difference between them in two time space to assess a sort of magnitude, the magnitude in this sense. So the question is also if this classification of the mosaic is available all through the all time series, or it's just calculated at the end or at a single time. Then a question about the accuracy, because maybe I missed this part on these maps. If the accuracies depend on the Earth observation satellite sources, if it's in some way harmonized in a single structure. The question is more or less it's, and also this descriptor, if they are also available through all the time series, or dependent on the type, the kind of descriptor.
Yeah. So yeah, thank you, Nicola, for your feedback and your questions. So answering the first one, so on the landscape mosaic. So this is exactly what we are aiming to look at. So I have a student, she just recently started to work in the frame of a certificate of geomatics we have here at the university. So she will explore, let's say, a time series of landscape mosaics and see what are the information in terms of change we can look at. So she will explore that. So I don't have yet the answer, but I suspect that yes, at least we can extract some useful information in terms of let's say, severity of magnitude of change. So I guess that's something really, really useful. But well, I would say, but probably by the General Assembly, but so by October, we can have already a partial answer on this aspect. Then the second aspect regarding the accuracy, obviously, because we are integrating potentially many different data sources together, each data source has its own, let's say, uncertainty. And then one of my colleagues here in our team, she's developing an uncertainty assessment framework related to that, to understand the propagation of the uncertainty through the different environmental descriptors. So this is something we are trying to develop and understand so that we can come up with a good measurements at the end. Obviously, thanks to the application I was showing, or quickly showing this EarthTrack application, then we can obviously validate also the map once produced on the ground. So we can set up, let's say, small citizen science activities within, let's say, for example, for the sake of the example, within the use case areas. And then we can ask the local stakeholders to map different points across the area so that then we can validate somehow also the map with, let's say, more traditional ways. But this is something, yeah, that's really a key issue. And then the third aspect related to the environmental descriptor. So what we are aiming to do, also just for Switzerland, for example, within the system we are building, is to identify those data sources that are really reliable, like the Copernicus services, because it's a key asset in Europe, but also the national ones that we have in Switzerland, so that we can really rely on them to build this environmental descriptor, and not to look at the last map published by a scientific guy, but again, it's just a one-shot data set. So basically the idea, because we want to have let's say, a kind of continuous system, and we want to be able to generate, let's say, at least a yearly map, then we need, for example, an NDVI map to map the vegetation. So, well, thanks to Sentinel-2, it's not going to be a big problem. And so on and so forth. So really building the system on reliable data sources. Otherwise, it could be really a big issue, I would say, at the end.
Okay, I have another question focusing on MONALISA project. We have 15 countries to analyze in the project. So do you think that it is possible to apply this framework in the project to integrate all this information and to harmonize all this information for the 15 countries?
I would say that potentially yes. It's gonna be I would say quite an effort, obviously. So we need some coordination inside the project, but I guess this could be feasible, let's say, because if we look at the data sources that we need, obviously we have some notebooks using the Google Earth engine, but we can imagine using the CDSE if we want to use more European assets. So to generate the basic layers, we can use, let's say, this cloud computing platform. So for the 15 countries, it shouldn't be a big issue. Then in Europe, we have the big advantage of having all the Copernicus services, and we already started also to map the different products within Copernicus, so that could be potentially useful in the frame of living Earth. So we have more or less, let's say, a clear vision of the different Copernicus layers that could be useful. Obviously, the best ones for us would be from the land monitoring service, but then we need to look at the other services also, because I guess there are other sources. And as it was also mentioned before, I think the EUSO system we can also extract really useful information from their data sources. So I think let's say with these three big data sources, we can come up at least with something that is consistent across the different countries and build something that is well connected, I would say, in that regard.
Saverio, we have time for a very quick question because we have.
Yes, it was simply a little comment. Really, we need to think to implement error propagation, especially at the local level. It becomes very important to know what layer insert in and maintain vagueness where vagueness is the information that we have. And so I think not only is important that all the layers have some uncertainty at the pixel level, or at least somehow this. And then we need some good thought on how really you propagate these things across. It's not easy because this is a categorical variable. And so probably we need to think in an anthropic framework more than in a variance framework. And so it's not easy, but
sure.
we can do.
Okay, cool. Thank you, Saverio. So we count on you.
Well, I don't know if Remus is still here. Remus, I don't know if you have any question regarding the integration with the MONALISA method. No? Remus? No, okay. He's not here. Well, is there any other question to Gregory?
Yeah, sorry, Diana. Just if we can have the access to any of the notebook, Jupyter.
Yeah. No, sure. This is something we're also setting up that with a GitHub repository, so it's going to be also available.
Thank you very much.
Okay. Remus is here. Remus, please. You have the floor. Remus, you are muted. We don't listen to you. Just a moment. Okay.
So while we wait for Remus, do you need, or I can make also a PDF version of the presentation?
Sure.
This is something obviously we can share across.
Thank you. Thank you,
Gregory. I will
Gregory.
send it to you, Daniela and Maya, and then we can share it.
Maya, yes, okay.
Within the consortium.
I knew that the discussion is going to be fruitful, so I left 30 minutes more. So you don't have to hurry. I know that everybody's busy, but if you discuss something, you have until the 4:30. Yeah.
Thank you.
Let's see if Remus can join us with the sound, or if there is any other question from other people. I'm still trying to Remus, if you can't join us with the sound, please you can write in the chat if you want. While we're waiting for Remus, I ask to Gregory and Nicola to think how to organize the collaboration for the implement this kind of framework in the SDG. If you think that there is the necessity to other people to work on it.
Do you hear me now?
Yes, Remus. Okay.
Oh, okay. Sorry for the issue. Thanks a lot, Gregory. So I have just a question. Do you consider to to use some well-known geostatistical procedures for trend detections in your indices, like for example, sense slope at pixel level for the estimation of the magnitude of the intensity of trends. For example, in NDVI units per year, and the man candle test. There are simply but very good non-parametric tests for trend significance, because somebody raised the issue of the confidence of the uncertainty. And for example, man candle can give us the statistical significance of any kind of environmental trends expressed, for example, in any units. And we can look, for example, to the p-value less than 0.05, so 5% error. So these two statistical tools are largely applied at pixel level. So sense law for trend magnitude per year, and for very important man candle test for testing the confidence, the statistical significance of your indices. This is the first question. Do you think you will use these tools at pixel level?
Yeah, thank you, Remus. Yeah, that's a really good point, and this is something we already have implemented in a project, in a small project we have at the subnational level here in Switzerland for monitoring forest health, and we are using satellite data from the Swiss Data Cube and the Living Earth framework, and this is exactly we have implemented that. Well, these two tests are already implemented, and this is the kind of information we can easily generate. So this is something we can, well, we have the elements, and then it's going to be super easy for us to provide that information on whatever scale we want to map.
Okay, and just one more short question. Maybe I didn't understood very well. So do you have right now the time series, the yearly time series of ecological data? So for each year, I don't know, in the last 30 years, or do you intend to generate the land cover, land use, land cover change based on supervision classification or something like that? Because I think there are some global databases, even global databases of 30 meters per pixel size, produced by Tom Hengel, I think, at global level with land cover and land use classes in the last 20 years, maybe, with machine learning algorithms. Maybe there are some errors at local levels, or maybe, I don't know, you will generate your own data based on supervised classification procedures.
So really the idea, obviously, is to generate our own product that are really tailored to the needs of the project. But yeah, definitely this is something we will also look at this Eco Data Cube that Tom is developing. So I was discussing with him in Rome last May. So yeah, definitely this is something we need to look at also carefully, because I think he also generated global maps for soil, for some of the soil attributes. So this could be also a potential source of information.
Exactly. I think they released right 1 month ago at most some soil attributes at time series level in the last 20 years with, for example, soil texture, soil organic carbon, and other soil attributes. So at pixel level at very high resolution. So this is impressive. But I knew that with some years ago, he generated also 30 meters, I think, that time series of global land cover and land use change. And he released the data, I think, on the Open Land platform, I think, something like that. This is the name of the... so you can check some good data there.
That's a really good point, indeed. Yeah, thank you.
Okay, thank you, Gregory. And Daniela.
Sorry, Gregory, have you generated the time series only for Switzerland at present, or also other?
So our team, so we are really working for Switzerland because we have this mandate to work for our government. But within my team here in Geneva, we have 2 colleagues that are involved in other European projects. but they really developed. They are the two guys behind Living Earth, basically, here in Europe, and they generated the land, and they are still generating the land cover maps for Wales. So they really generated the time series for Wales. And in Wales, what is really, really interesting, I guess, because one of the nice also feature of this LCCS classification, then because it's not a fixed class, I would say, like just a forested area, then you can somehow, with the use of additional descriptors, then you can develop translation schema from the LCCS to, for example, let's say the ESA CCI or the IPCC classification. But what they did in Wales, they even mapped habitat. So they translated the land cover map to habitat maps. So they, in one shot, let's say, they generate these different key informations. And this is something, well, in Switzerland, we are really working on that, also on the translation to habitat maps on a yearly basis. But if there is a need also within MONALISA, then this is something we can investigate and take some time to look at.
Okay.
Daniela, just one small observation.
Okay.
You asked me about the Medalus model or something like that. If you want, I don't know, or if everybody or somebody want to explore some connection between our product with the Land Degradation Susceptibility Index and the indices of Gregory, the only way is we have only one static databases of land susceptibility to degradation, which will be representative for 2018. So we don't have time series of Medalus model. And the only way to make some correlation, for example, between the results of Gregory and our results is to use some mean multi-annual values of Gregory indices and to correlate with our product, because our product is a single one product, not time series, not temporal. So the only way is to model the Gregory time series, the temporal database in the static way. So this is the mean multi-annual value approach. This is the only way, and to make some correlation just in case if somebody want to make some statistical correlation between our susceptibility model and the ecological temporal data of Gregory. I think I make understood. Did I m-am făcut înțeles, sorry for my English right now. I don't find the word. So do you understood what I want to say? Like that?
Yes, I see. I don't know if Gregory is okay. I see.
No, I think that's that would be good to do this kind of exercise, because I guess that we need to come up also with something. I guess, at least from my point of view, we need to something more integrated and really look at this really different dimension, because I think that the sensitivity is one aspect, but then the SDG 1531 is another aspect we need to look at. So yeah, definitely.
So the problem is that we have the static data and Gregory will have the temporal data. So the only way to compare the databases is to use the mean multi-annual raster value of Gregory data sets and perform some potential correlation with our susceptibility model, which is representative for one single year.
Yeah,
okay.
Exactly. That's
so I wanted to say.
I think that we can do a tentative to integrate this data, because the method that Gregory proposed is a land cover map that include also functional information, not only static information on the land cover, and maybe it could be useful. This information could be useful to do the ranking of the weight of land degradation of each of the indicator of land cover, because it contains more information regarding the land cover, not only the physiognomy of the land cover. So I don't know how, but we can think to do a link between this kind of information and the Medalus ranking regarding the land cover indicator.
Not necessarily on land cover. For example, NDVI can be, in theory at least, correlated with high susceptibility level of land degradation. Just if somebody wants to make some links between the data sets. This is all I wanted to say. Thanks.
Okay.
Thank you.
Any other question? So if there are no questions, I would like to thank you all the people that participate to this seminar, or people that make questions. Thank you very, very much. The recording of this seminar will be available on MONALISA YouTube channel. And the presentation of the website. Thank you, Maya, for this information. Maya will send the links to all the material to all the attendees of this seminar. And I thank you very much, Gregory, for your time, for this interesting presentation. And I think there are a lot of information that will be useful for the development of the MONALISA project and our work package in particular, but I think that also the other colleagues, the other partners involved in the project, they can use this kind of information. Thank you very much, Gregory.
You're welcome.
Thank you, Maya, and the Innocence colleagues for organizing this seminar, for helping to organize this seminar. Thank you, everyone, and goodbye.